Alrighty, if you missed it today, these are the introductory work problems we did. For our first one, we've got force and displacement, both in the same direction, which means the angle between the two of those is 0. And so when we plug in to our equation, work equals force times displacement times the cosine of theta. We've got 100 Newton force times 5 meters displacement times the cosine of 0. Cosine of 0 is 1, so that's 5 times 100, or 500 joules. For our next one, over here, diagram B, we're now applying a force at an angle. Maybe this is you taking your luggage through the airport, right, and pulling kind of upwards at an angle. Maybe this is you pulling on your dog's leash. Maybe this is, who knows. But the angle between the force and the displacement is 30 degrees. So when we plug in, we've got that same 100 Newton force, same 5 meter displacement, but now the cosine of 30 degrees. Cosine of 30 degrees is 0.866. Multiply that by 500, sorry, and you get 433 joules. Last one, a little tricky. You've got to figure out what the force is. So whatever that upwards force is, whether it's a push, like an applied force up, or whether it's a tension from maybe a pull on a cable, like an elevator, whatever it is, since we have a constant speed, that means that these two forces are going to be equal and opposite. And since that's the case, and the bottom one is gravity, we know that gravitational force is equal to mass times gravitational acceleration. We know what that is. And so we can solve for that. The force is mg, which is 15 kilograms from right there, times 9.8 meters per second squared, times the displacement, which is 5 meters, times the cosine of the angle between the force, which is up, and displacement, which is up. So that's the cosine of 0, which is 1. And when you multiply all this stuff out, you end up with 735, I think is the answer. And that's it.